Hello, welcome to RC Video Reviews. This is the fourth video in a 5-part series on setting up Rotorflight and the Nexus fly barless. Tonight, I'm joined again by Rob. Rob is a OMP team pilot, and he is a very early adopter of Rotorflight. And what we're going to do tonight is basically cover the motor setup. So there's a lot that happens in the motor setup on a helicopter. You've got to get your telemetry working. You've got to get your governor set up, your RPM, your radio set up for all of those features. And then also we're going to cover ESC calibration and how to set up auto rotation on the Nexus fly barless as well using Rotorflight. So with that said, I'm going to let Rob start guiding us through the topic for tonight. And we're going to get started with the wiring. So Rob, say hello and take it away.
Hey. All right, so most ESCs, like the Hobby Wing and Scorpion that most guys use, for telemetry, we're just going to take it from the programming port. You'll have to look it up if you have anything else. And in this case, we just ran that wire, just the signal pin, straight to the S-bus port.
Okay, so I'm zooming in a little bit, and I'm just going to use my little pointer here to show you guys right here. That is the signal line on S-bus. Let's see, it's not going to focus, huh? There we go. There's the S-bus port, and there's a signal line that goes to the programming port on the Hobby Wing. So there's that one.
Yeah, and that can go to any of the UARTs. Just needs to go to the RX pin of any of the UARTs. So any of those four ports on the top as well.
Right, so you could use this one, whichever. Is DSM a UART, Rob? It is, right?
Yeah, it's its own UART, and it's actually an RX, so it's already set up.
Okay, so if you have the connector for that, you could plug in there as well.
Yeah,
okay.
In fact, if you're coming from something like VBAR or Spirit, and you already have the telemetry wire for that, you can just plug it straight into the DSM port.
Okay, perfect. And then the next one, there's another important wire.
Yeah, so in this case, we have RPM from the ESC, because this is a standard ESC.
Right. We'll talk about Dshot in the end, because that's a digital protocol, but in this case, standard ESC, that's the RPM signal.
Yeah.
Okay. And then the last connection is just the standard signal wire. That's the straight up, that's your power, ground, and signal wire to the ESC. That's the last connection. So those first three things you need to do. S-bus comes from your programming port. RPM is your RPM signal, and then your ESC is your standard signal connection, just on like any other ESC that you connect to a model. Okay, Rob, what's next? That's physical. What's next?
All right, so let's move on to Rotorflight Configurator.
Okay.
And let's start off in the configuration tab real quick.
There we go.
The one thing we need to do if you have ESC telemetry is to make sure and enable it on the UART that it's on. So in this case, we have it on the S-bus port, and you can see that's set to ESC telemetry. If you don't set that ESC telemetry to one of the UARTs, it won't allow you to pick a protocol. So if you're stuck with disabled, that's why.
Yeah, that actually got me the first time too, because I went in to the protocol trying to see what the options were, and I couldn't select anything. I thought, okay, but yeah.
I think if you move the port, it might reset your ESC telemetry setting.
Okay.
So if for some reason you switch it to port A or something, and you save it, it might reset your setting in the motors tab.
Right. So we talked about using the UART up top. So if you use this DSM UART, for example, then you would put your ESC telemetry here instead. But obviously it's grayed out right now because I have it on the S-bus port. So it looks like you can only choose one place to bring in ESC telemetry.
Yeah, exactly.
Okay. All right. What else on this screen?
And I think that's it for this screen. So we can go ahead and touch on the receiver screen real quick.
Okay.
So in your case, you're running Express LRS with D500 packet rate and wide switch mode.
Yep. And we'll show you that configuration on the radio in just a little bit. So hang tight.
Yeah. So that means the throttle channel, which is on channel 6, only operates from 1,000 up to 2,000 microseconds. So that you need to make sure and adjust those two settings. The arming value and the 100% throttle value.
Yeah, so what he's referring to, guys, right here on the left-hand side, I'm using a switch instead of a stick. And for that reason, the lowest value on the switch configuration is 1,000 and the max value is 2,000. So you need to make sure you set that, because if not, it won't arm. And then the throttle channel for 0% then is just 1,010, and that's sufficient to activate your throttle. And there's one other thing let's point out too, Rob, on this one, and that's the throttle percentage for auto. Let's point that out as well, because that's a good spot to check your work, right?
Yeah, so if you want to have auto rotation bailout, you need to set the throttle needs to be between 0% and 20%, as indicated right there where the mouse cursor is.
Right. So right now I'm putting it in auto rotation mode, and I'll show you that setup in just a minute. But you see that value at 1110, that has to be, that's what Rob's referring to, has to be between 0 and 10. And that's necessary in order for the auto rotation parameters to take effect, which we'll cover later. So just make sure that if you're auto rotation mode, this needs to be somewhere between 0 and 20%. Okay.
Yep.
All right. Anything else on that page?
I think that covers it on that page.
Okay, so that'd be a good time then to jump into the radio configuration. So let's do that real quick. And I've already done an EdgeTX configuration, but I did want to share what a change, because I've been sharing my configuration files as we've gone along. And this is going to be a V2 configuration. The reason it's a V2 configuration is because I've changed the way I handle the motor. So in my case, initially, I simply had my idle up on one switch, and this basically was motor off, and then idle up 1 and idle up 2, and that worked. But then I realized if I were flying and I went from, say, idle up 2 and push down, I potentially could turn off my motor. And I really didn't like that idea, so I wanted to make a switch and separate the motor arming. And while I did that, Rob said, yeah, you can also incorporate your auto rotation setting on that motor arming switch. So I want to explain how this works on my radio first, and then I'll show you the configuration. So the first thing that we do is we arm Rotorflight, and that's this switch right here. That allows me to arm Rotorflight. That's the Express LRS packet channel 5 that does the arming signal to let Rotorflight know it's armed. So that's what that's for. And then this switch, this is the motor. I'm using SG down. This is motor off, and then this is auto rotate, and then this is motor on. So motor cut, auto rotate, and motor on. And then over here, I've got idle up 1, idle up 2, and idle up 3. Okay, so that's how I control my motor. In order to spool up my helicopter, I start with all these switches down. I arm Rotorflight. I go into auto rotate, let it get a little bit of speed. Then I turn the motor on. That activates my first RPM level, idle up 1. And then I can go in using the governor setup in Rotorflight. I can go to idle up 2 and idle up 3. So the radio configuration to make all that happen is on channel 5. That is the standard Rotorflight arming channel right here. And then on channel 6, that is my motor cut. So there it's set -76%. That is auto rotate. And I'll show you, that's the one where I got the 10% on my screen, on my Rotorflight screen. And then this is full power, 100%. And then when I go to motor active, the RPMs are governed by the profiles in Rotorflight. Okay. And then I select those profiles with my idle up switch, which is channel 9, I think. Yeah, that's channel 9. So there's idle up 1, idle up 2, and idle up 3. Okay. So that's my EdgeTX configuration. I'll show you the mixer real quick so you can see it. Channel 5 is arming. Channel 6 is SG. It's simply listed at 100%. That activates my motor. Notice I have a motor curve. I'll show you that motor curve. And then channel 9 is SA, and that's my idle up. All right, and that, or profile. That's why I have that /pro in there. So now let me show you my curve. I'm using the MOT curve. I'll just click on that, and then there's my MOT curve. And MOT curve, that is simply applied to this switch, and that's what gives me either motor off, auto rotation, or 100%. And then the governor is managed by the profile. The head speed is managed by the profile in Rotorflight. All right, so that's my EdgeTX configuration. I'm going to call that version 2. I will post that in my Discord. So if you want the configuration for Rotorflight and EdgeTX, that'll be available in my Discord in a zip file. This will be called V2, and I'll put the word auto rotate in there so you understand this is what enables that auto rotate config. So that's it on EdgeTX. Let's get back into the desktop, and we'll go back to Rotorflight now and continue working there.
Okay, all right, Rob. So the first thing we're gonna cover are just your standard PWM receiver ESCs, like John said earlier. So like your Hobbywing, Scorpion, YGE, ZTW, etc.
Okay.
So we can go ahead and go over to the Motors tab.
Okay. Then
sort of glossed over this before, but the first setting is going to be PWM for all these standard type ESCs. If you have one of the other ones, you're going to know you have one of the other ones.
20 seconds.
Right. Okay.
So this is already set to PWM.
Right.
In our case, we have a Hobbywing V4 Platinum, so that's what the telemetry set to.
And if you have any of the other Scorpion, YG, ZTW, Open YGE, you'll see those listed. So feel free. OMP Hobby obviously is listed there. So just pick the protocol, the ESC telemetry protocol appropriate for your hardware. In my case, Hobbywing V4. Okay.
And then we enable RPM sensor. That's actually turning on the RPM port for the RPM signal.
Right. That's the yellow wire, right? That's coming in case you're wondering. That comes in right there on that yellow wire. So that's what that toggle does, is tells Rotorflight, hey, that's a RPM signals coming in from the ESC.
Yep.
Okay.
And then the ESC update frequency, you can just leave that default. If you want to crank it up to 330, you can. If you have a very old ESC, like a very old Castle or something, you might actually need to drop that down to 50. I saw recently some people were having trouble with that.
Okay.
Let's see. And then the motor stop throttle PWM, you can just leave that at default 1000. There's really no reason to change it. You'll know if you need to change it for some reason.
Mm-hmm.
And then the 0%, you can leave that default as well. We'll actually adjust that a little bit later after we calibrate the ESC.
Okay.
And then the 100%, again, just leave it alone. If you know you need to change it, you'll know.
All right. Now this next section is important, and this one has gotten me at least twice. And I can tell you, use the tooltips, hover over the tooltips, because the first time I did this, you get crazy RPM values if you do it wrong. So when you hover over the tooltips, you'll see where it says use motor pinion : main gear tooth count. My issue is I keep putting the big number first, and that's wrong. In Rotorflight, it's reverse. You do the motor pinion first, so that's 21 in this case, and then your main rotor gear is the second one. So that's tooth count. Again, this is not Helicopters 101, so I think most of you won't understand the need for this. Is in every single fly barless I've used, you've had to include this information. So just pinion count there and your main rotor gear there. And then the same for the tail rotor.
Yep, and these are important for Rotorflight because if you're going to use RPM filtering, which you really should use, you really want the actual tooth count so you can get the exact ratios. You don't want to. Sometimes the manufacturers give you a rounded off ratio you could put in there.
Mm-hmm.
So stick with the tooth counts if possible.
Right.
And I also wanted to mention that some helicopters have a multi-stage main rotor ratio,
like the Kraken,
the Raw 700 and Kraken. Yeah. Forgot to send you the link, but there's a walkthrough, or in the Rotorflight walkthrough on the Rotorflight website, there's a cheat sheet there for how to set those ones up. And if you have something that's not already listed there, it tells you how to calculate the right numbers.
Okay. We'll put a link for that in the description after the video posts. We'll come back to that. But we will have a link in the description for you guys to go check that out if you've got a transmission, like a Kraken transmission, for example.
Yeah, maybe we'll do your Kraken later.
Yeah, that'd be a good one. And then the main motor pole count.
Yep, just the actual pole count. I know a lot of other systems actually ask for you to divide it by 2, but this is the actual count.
Okay. And that's the number of magnets on the motor bell. You know, I'm not sure if I ever checked that on this motor. I'll have to go back and check. Oh, it is 10P. There it is. Yeah, I got it. It's 10P.
Nice thing with Xnova is they just put the pole count right there.
10P. So that's how many poles I have on mine. So 10. Looks like I got it right. Okay, good.
Yep.
All right.
And then we can move down to the governor section.
Right here. Yep.
So there's, what is there, 5 governor modes?
Off, pass-through, standard, mode 1, mode 2. So.
Yep. So off is just off. It's just going to pass whatever your transmitter is sending straight to the ESC. Pass through it'll use all the startup and tracking and recovery times that you see in here. So it'll do soft start and all that stuff for you, but it won't do any governing. It'll just soft start up to your throttle percent basically.
Okay.
And then standard is that's governed, and it doesn't have any of the pre-compensations, like when you go to move the collective or cyclic. You can adjust it to preemptively give it a little extra throttle. Standard does not do that. And then there's mode 1, which is standard, but it has all those pre-comps. That's the mode that pretty much everybody's going to use if you're going to use a Rotorflight governor. And then there's also mode 2, which is mode 1, but it actually monitors the flight pack voltage. So it can actually, it has even more pre-compensation because it can see that the voltage dropped and immediately increase it.
So Rob, what would be the gating factor between mode 1 and mode 2? Like, how do you know, like when I read this, I want to put mine on mode 2 because it says proactive battery voltage sag compensation. I kind of like the sound of that. So why wouldn't I use that on my hobby wing?
So the catch with that is you need fast voltage telemetry.
Okay.
And as far as I know, the best way to do it is with the flight controller, where you can actually give it the flight pack voltage directly, so that it's using an onboard ADC, analog digital converter.
Okay.
Or I've seen that BL Heli 32 ESCs and probably any of the similar ones like Blue Jay and whatnot. I think those put out telemetry fast enough that you can use those as well. I've tried it personally with Scorpion and Hobby Wing, and I've had mixed results with it that kind of left me wondering what's going on.
What kind of results do you see? Like, what would somebody see if they saw a bad outcome here using the wrong governor mode, like between mode 1 and mode 2?
One of the setups, or maybe 2 of them, it just never actually reached the full head speed in the profile for some reason.
Okay.
Like it kept coming up like 300 RPM short.
Oh.
And I wasn't sure what was going on until I switched it back to mode 1, and all of a sudden everything's really fast.
Okay. All right.
Not sure what other symptoms there'd be. Possibly some tail oscillations that you can just never tune out.
Okay. All right. So in my case, just for the record, on mode 1, the Hobby Wing ESC, I've flown this buddy and it did fine. It hits my RPM targets. I didn't see any weird oscillations. And then I can also tell you on my raw, which we'll cover later, that uses Dshot. That's a BL Heli 32 ESC. On that one I have on mode 2, and that also performed well. So I guess the advice is simple. If you're not in a BL Heli 32 with like Dshot, then you stick with mode 1. And if you do have a fast BL Heli 32, then you can try mode 2 and see if everything works the way you expect it, right? Is that the guidance?
Yep. Pretty much. Mode 1 for if you're planning to use RF governor, just use mode 1, basically.
Okay. Next, there's a couple of other factors in here. Startup time, spool up time, tracking time. I think those are all things that you defaults are probably okay. I didn't mess with those at all. The handover throttle. Yeah, go ahead.
So the handover throttle, that is at what point your transmitter throttle switches from direct control to the governor. So this is set to 20% right now. So that means anywhere between 0 and 20% from the transmitter, it's just going straight to the ESC.
Okay.
It's not running through the governor or anything.
Right. Okay. So in my case, in my auto rotation curve, I'm below 20%. So in that spot, it's my radio that's telling the ESC what to do. The fly barless is passive in that state, right?
Yeah, exactly.
Okay. And then when we go into that idle up, motor on, any of the idle ups are all at 100%. So in that condition, the fly barless then is performing the governor function.
Right.
Okay.
Yeah, and also want to mention that when your throttle's at 100%, when you're using the governor. It targets the head speed in your profile, but you can, if you want to reduce it a little bit, you can. So if you go to 90% throttle, it'll be 90% of that head speed.
Okay. Okay. Good to know. All right.
you can
So,
go
so
down
there you
but
go.
not up.
100% throttle is the target, in the head speed target in the profile, which we'll show you in a little bit. All right. Cool. Yeah, that makes sense. So perfect. All right. Is there anything else we want to cover in here? Do you want to get into auto rotation or?
Yeah, let me touch on the startup and spool up time real quick.
Okay.
So the startup time, that's sometimes you need to mess with that and increase it a little bit if you have an ESC that has a very, very slow built-in soft start. Like I know one of the hobby wings, I think the 200 amp, has a very, very soft start, and it kind of throws things off. And the only real way you can deal with it is to increase the startup time. I'm not sure exactly how high you have to go for that, but for most ESCs, you can actually leave that one alone. There's really no reason to mess with it.
Okay.
If you want your helicopter to spool faster, spool up time is the one to mess with. The default's pretty soft. I think the default's actually 15. I usually drop it down to 10 or so. Smaller helicopters, I can take it all the way down to 7 sometimes. But if your spool up time's too long for you, that's the one that you want to start fiddling with.
Okay.
And then tracking time, that is, say you're switching between profiles with different head speeds, that's how many seconds it's going to take to switch between those head speeds. That's another one where the default is like 2 seconds, I believe, which I find a little bit too fast. So I usually bump it up to about 3 to 4 seconds. In this case, we went to 5, which is fine.
Okay.
And then recovery time, that's just if something goes wrong, like you lose head speed, just for some reason you lose the RPM signal, and you get it back really fast. That's just how fast it tries to recover it. So if that's happening, you got a problem that you need to fix.
Okay.
You can just leave that at default.
All right. And then now we're in the auto section, the auto rotation section. So these are the parameters that we talked about earlier, that if you cross, if you're in that 0 to 20% range, that the auto rotation parameters take effect. So if you want these parameters, you have to have that throttle in that up below 20% or below.
Right.
Okay.
Yep. And then so auto rotation bailout time, I believe by default is 0. That's how long it's going to take to spool back up from auto rotation bailout mode.
Okay.
I just set it to 1 typically. You'll have to play with that with your helicopter to see.
Okay.
Auto rotation timeout. This is the other important one. By default, that's 0, which disables auto rotation bailout. So if you actually want to use it, you need to set that to a number. In this case, we set it to 30. So that means it can be in auto rotation bailout mode for up to 30 seconds before it just assumes maybe you forgot that you're in bailout and switches back to normal idle, which means it'll spool up slowly.
Okay.
So that means if you go into auto rotation bailout, bail out within 30 seconds. I think you can set it up to 60 seconds if you want.
Okay.
And then there's auto rotation minimum entry time, and that is how long you need to be with the governor active before it'll allow it to go into auto rotation mode. So that means you have to spool up and be at your head speed. The default's 5, so that means you need to be at your profile head speed for at least 5 seconds before it'll allow it to drop into auto rotation bailout.
Okay. So let's give the example of auto rotation on this one before we go past that point. All right. So what I'm gonna do is I have to, in Rotorflight, because we're connected, I have to enable arming. So I'm gonna do that, and then after that, I'm gonna switch over to the big camera. I'm gonna make sure everything's disarmed first. Okay. I'll switch over to the big camera so you guys can see what'll happen during an auto rotation. So I've got my everything is stopped, obviously halted at this point. And I have to make sure that there's no no contact because we're about to spin things here. So right now everything's disarmed. What I'm going to do first is just arm Rotorflight by turning on my arm switch, and then I'm going to go ahead and put my motor cut into auto rotation mode, and that should get it spinning at my auto rotation RPM, which is just enough. The curve is set just enough to get the head to spin. So I'll show you the curve in just a minute. We'll get back to that. Now I'm going to go ahead and activate the motor all together. So when I do that, it should hit my RPM on my first idle up, which is now down. So I'll go ahead and activate the motor active, and we'll see RPMs climb up right here to my idle up 1 speed, which is 2,500 RPM. All right, now if I go into auto rotation mode, I'm gonna move out of motor on to auto. So there's auto, and you can see my RPM will drop back down to about 800, give or take. And now that auto rotation bailout, this is where we'll spool back up quickly. I'm gonna go back to motor active, and within a second, we go right back up to my designated head speed. So that's the auto rotation configuration that we were talking about. Now, I told you I'd show you the curve real quick here. I'm going to go ahead and bring up the curve, and let's see here. Remember, it's the MOT curve. And I'll show you how I set that real fast. So the way I set that is using, I'm going to make sure I don't bump my radio into a moving part here. The way I set that is this middle value right here is set at -76. So you basically want that to be the lowest number you can get while it's to cause it to spool up. So there's -80. I'm going to bring it up 1. There's 79, 78, 77, and there's 76. So that's the lowest value I can have to keep the head spinning, and that's my auto rotation head speed. Okay, so there we go. I'm going to cut the motor now, and now I can put that back, and we can get back into Rotorflight. Hopefully that makes sense. I'll check comments for questions. I don't see any, but if you do have any questions on that setup, now's the time to ask. Okay, Rob, so let's see. We were on the motor page, and we were going through the auto rotation settings. Is there anything you would add to that little demo that we just did?
Yeah, actually, I just need to mention that I think I said it earlier, but just again, to be able to go into auto rotation bailout mode, the throttle needs to be between 0 and 20%, as it shows in the receiver tab or setup tab. Yeah, receiver tab.
So here's the one he's talking about is channel 6 right here. So when I put my switch into auto mode, I'm at 10%, and that's my curve for -76. Okay. All right. Should we talk about Express LRS now, because we kind of stumbled on that one using hybrid versus wide, so maybe we should show that. Would that be a good idea?
Yeah, since we ran into that little thing with the hybrid thing.
Yeah. So what we're talking about there, I can move the helicopter out of the way. We'll just do a little zoom in. I just want to give you a look at my Express LRS settings, because when I set my Express LRS up, I used oops, wrong button. I set the mode to hybrid, and when I did that, I didn't have enough resolution to allow the switch position to go between 0 and 20. It went from 0 to 26, which doesn't allow you to go into auto mode. But by setting my switch mode to wide, that gives you 64 dividers or 64 positions, which did give me the percentage I needed for the first switch position. So in my case for Express LRS, I'm using D500. I have a telemetry ratio of 1:4, and I'm using a switch mode of wide. There are plenty of other options you can use. 333 with 16 divided by 2 is fine as well. That gives you basically 16 fully proportional channels. But in this one, we're basically getting the way Express LRS was intended to work with Betaflight and Betaflight derivative flight controllers. So I've got a nice fast packet rate, nice fast telemetry rate. The D means we get dual packet transmission, redundant packet transmission, and the wide switch mode is enough to give me the resolution I need to control the helicopter. Okay, anything to add to that, Rob?
No, not really. Well, you don't need to run D500 or anything like that. You can run 333 or 150 hertz, 100 hertz if you want.
Sure. Yeah. This is fast. 500
Yeah.
hertz is super fast.
Just because we can.
Yeah, just because we can. It's just giving the fly barless lots of RF information.
Yeah, it gives it a lot of information so it can smooth the inputs a little better.
Yeah. Okay, so that's it. Let's get back to the desktop, and we'll pick up where we left off. Is there anything after the auto rotation you want to cover, or?
Not really. Those are all pretty much things you don't really need to touch. If you do, you'll know it.
Okay.
And honestly, I haven't really touched any of those cutoffs. I never really needed to.
Me either. Everything I have has been flying just with the auto rotation parameters, and that's it. Nothing beyond those. Okay.
Yeah, pretty much.
What's next?
All right, so we can go ahead and show how to calibrate a PWM ESC.
Okay.
So we'll want to go ahead and unplug the battery.
Okay. Unplug the battery. Do I need to unplug Rotorflight from the computer?
No, you can need that plugged in, actually.
Okay. Leave that plugged in.
So we'll scroll up a little bit to the motor override.
Yep. Right there. Motor override.
Yep. So you can turn that on and then drag the slider over to 100%, which is safe to do right now because it's not plugged in.
Okay.
And then now you can plug in your ESC and wait for your calibration beeps, or however your ESC does it.
Now, before I do this, I know the answer, but people that aren't familiar aren't going to understand this. Why do we not have to worry about the radio? Like, normally when we do a calibration, we're putting our throttle, and most people associate the stick with the throttle, but why don't we have to do this on the radio? Why is that true?
So we're just bypassing all that since we're setting the output PWM values in the left column there, the 1000 and 2000.
Mm-hmm.
That's handled. Rotorflight's handling what it's sending to the ESC. It's not necessarily passing through directly from the radio.
Right.
And we're using override to make things easier, because otherwise we'll have to turn off governor and a bunch of other stuff in order to be able to actually achieve 100% throttle. And in fact, I think with the way Rotorflight works, you probably can't even calibrate it the usual way. You have to do it with the override.
And I'd also point out that when we have full throttle, remember on our receiver setup, we are at 100%, right? It's because we configured it as 1000 as the low, 2000 US is the high. That's why we see 100% here. So on the motor tab, when we turn on 100%, that equates to the full on position of the switch. So that's the other reason you don't need to worry about the radio, because now Rotorflight is saying, hey, this is what it looks like at 100. Okay.
Yeah, and with the safeties in Rotorflight, you actually can't do it any other way, as far as I'm aware.
Okay, so now we'll and by the way, this is a critical step. You don't want to forget this, because otherwise your ESC is not going to be operating at its full duty cycle. So we'll go ahead and plug this in.
Yep.
There's the 2 beeps, now down to 0.
And then you can disable or that, either one. And that's it.
Oh, it didn't like that. We're going to have to do it again. Oh. It's going beep, 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 beep. It didn't like that. So just disable, huh?
Probably took too long. Either one.
All right.
Probably just took too long.
Try it again.
Oh, it probably started reading off settings.
And then disable.
Yeah, I do it that way because it's faster than the slider.
Okay, there we go. So that's calibrated now, right?
Yep, that's calibrated.
Okay.
And then this next part is, I would say, pretty important for ESC or for Rotorflight governor. It's to ensure that it has a nice soft start, or as soft as that ESC will allow when you spool up. So we already adjusted. It's the 0% throttle PWM value. I believe the default is 1070 or so, and that's usually a little bit too high. The way you adjust it, what you want the number to be as low as possible, but the motor will still start if you enable motor override and set it to 5%. And I just know from experience that hobby wings tend to like somewhere around 1035.
All right, so what do I do here?
Yep.
Let's walk through the steps.
So enable the motor override.
Enable motor override.
And then drag it to that first hash mark, which is 5%.
Okay.
And the motor should start up.
It does.
Yeah, so this is already all set up. But what you can do is drop it down to maybe 1030, and then save and reboot, and then show that it doesn't start up.
Okay. 1030.
Yeah.
We have to turn that off, I guess. Save and reboot. Okay. So I'm at 1030. I hit motor override, set it to 5%, and it doesn't start.
Yeah, and that's very important, because if it doesn't start at 5%, Rotorflight's going to have a hard time. It might even just never spool up.
Okay.
So you do need to get that correct.
So we'll bring this up.
We know from trial and error already that it's 1033. What I usually do is move it in steps of 10 if I don't know where it needs to be.
Okay, I just set it to 1033 and it didn't start. Should I keep going?
No, you actually have to. This needs to be fixed.
That's
eventually,
right.
But you have to save and reboot.
Okay, that's right. Okay.
And there is that one setting that makes that a lot easier.
Yeah. Yeah. Okay, so we're back on the screen. Turn that on, 5%. And my motor starts. Okay.
Yeah. And we figured out that 1033 was what this one needed.
Right.
But that gets you the best possible spool up with that ESC.
Okay. Good. That's a good pro tip right there, because that's good attention to detail there. Okay.
It's something I used to skip over a lot, and I finally did it and kicked myself for not doing it sooner.
Yeah.
So it was so much better.
All right. What's next?
That's pretty much it for a PWM ESC.
Should we maybe take a look at the profiles real quick and show the RPM settings?
Yeah.
Let's do that. Okay. All right. So profiles, the way I have mine set up, if you look at adjustments, here's a quick look at my adjustments, and you can see the profile selection I have on aux 4. That's my idle up switch. All right. That's this guy right here on the end. That's my idle up switch. And this is the profile selection. Notice I've got 3 values here, 1 through 3. And when I move this, that allows, you see this red bar moving from 3 to 2 to 1. And that the action taken is profile selection. So now on profiles, we talked a little bit earlier about this idea that 100% targets your head speed. You set the head speed right down here. So my idle up 1 is 2500. If I switch to idle up 2, my target head speed is 2800. And if I switch to idle up 3, my target head speed is 3000. So that's where you change your RPM values in Rotorflight. They're attached again to the profiles, and again, this is my idle up switch. So another thing that you'll also notice, we'll get into this in a later video, is that this also controls your PIDs, which makes sense when you think about it, because you're changing your head speed. You probably are going to have some PID modifications you want to make as well. So that's why I just wanted to cover that, so you guys had a clear understanding of how to control your head speed when you're using Rotorflight as your governor. And this is where you do it. Okay?
Yep.
All right. So that's it, right? That's the entire motor configuration. That's everything you need to know?
Pretty much.
All right.
PWM, yeah.
So next I'm going to bring the raw in, and we're going to show you the differences in the configuration for a Dshot ESC. So give me just a second. Okay, this is my raw 500, and on this helicopter I have an AM 116 ESC that is running BL Heli 32, and the protocol is Dshot. So we're just going to walk you through a couple little minor modifications. Most everything is the same, but there are a few differences, and we wanted to go through what those are.
Yeah.
So
if anything, it's actually easier. It's all going to be in the motors tab.
Right. Okay. So
and all that is ESC protocol is going to be Dshot.
And we want to use 300.
300.
Right.
Yeah, ideally 300.
300.
And then, of course, we have the telemetry hooked up. So it's a similar thing. I don't think they call it the programming port on this one. It's just the T.
Yeah, the T. Yep.
Which is telemetry. Which I've seen on other BL Heli-based ESCs.
Right.
And that's hooked up the exact same way as straight into S-port. And then that's the other critical thing, is you want to turn on Dshot RPM telemetry. That's assuming that your BL Heli ESC has Dshot or bidirectional Dshot, which at this point most do.
Yeah.
And since we're using that, we don't want RPM sensor turned on.
Right. So the important thing about the Dshot RPM telemetry is that's actually conducted over the signal wire, right?
Yeah, exactly.
Yeah.
So it's the same wire as the standard ESC wire.
Standard ESC. So you don't have that standalone yellow wire that goes into the RPM port on this one. You don't need
That's
it.
The full thing.
Yeah,
you get one port back.
There you go. Okay. And
then that's pretty much that's it for this, because you don't have to do that that calibration we're talking about with the 5% with the override, because Dshot doesn't require that.
Okay.
And then because we're using BL Heli 32 telemetry, we can go ahead and use mode 2.
Yep. And that's what I have this one set on, as mode 2.
I will say that this one works well. I know the 116 works well. You'll have to experiment with your other, if you have a different brand ESC, because they don't all have perfect telemetry. So if you're getting some funkiness with your head speed, or you have some kind of shake that just won't go away, try dropping to mode 1, see if that fixes it.
Okay. And I'm going to go ahead and add my auto rotation bailout time. It was 1 second and then 30 seconds. Was that right?
30. And then I set the minimum entry to 0, because it defaults 5. So that means you need to be at your head speed for 5 seconds. I figure 0 is fine.
Okay. So I'll go ahead and add those parameters in for this one. And there we go. So I think this one's configured now for auto rotation as well.
Yep.
All right. I don't see any questions. Let's see. Wait, Robert has, what will happen now? BLHL 32 is no longer available on new ESC. So there's probably going to be some ESCs out in the retail channel that you can still get BL Heli 32. And I know like the AM series, they'll probably still have it. But Robert's right. Now that that's gone, you're probably going to be looking for AM32 ESCs, or you can just stick with the PWM ESCs like we saw in the Hobby Wing. They do work. It's effective. I mean, I didn't have any problems with it. It's just a different technology, right? Slightly different configuration, which is why we showed both.
Other than gaining one port back from not needing the RPM wire, there's really no real-world benefit to it, to be honest.
Yeah.
It is cool that you can program it with pass-through, because you can do pass-through programming for the BL Heli 32 ESCs.
Yeah,
meaning software. You can just use go through the Nexus to program it.
Yeah.
But otherwise, there's no real big benefit. Scorpion, Hobby Wing V5, Platinum V5, and YGE pretty soon are actually going to get the ability to be programmed through the transmitter through Rotorflight.
Cool.
It's already working. It's just not in a release yet. And hopefully we'll see more ESCs added to that. So that's not even a big deal.
Yeah, hang tight. And then Robert also made a point of letting people know that my switches are a little bit different than the stock Radiomaster. So on my right-hand side, for a stock TX16S, that is a momentary switch. And you can see in the video, I've converted mine to a 2-position, and I've moved the momentary over here to SF. So that is my momentary switch. So did want to point, thanks for mentioning that, Robert. Obviously, set up your switch config that from EdgeTX in a way that works for you. And again, I will have the configurations for the RAW and EdgeTX, and then I'll go ahead and add the buddy configuration in EdgeTX as well into the Rotorflight channel on my Discord. They'll be in a zip file. They're pinned at the top. And keep in mind, this will be a V2 setup, because with V2, I added the auto rotation parameters to both EdgeTX and the helicopter. Okay. All right. That wraps up the motor configuration video. The next video will be the final one in the series. And in that video, we're going to cover PIDs. So we're going to talk a little bit about how PIDs work, what you're looking for, a little bit about the default values, and we'll talk a little bit about when you're flying, what to watch for and what things you might want to change while you're flying if you see a problem that you like to correct with your PIDs. So that will be the last video in the series for the front to back configuration of Rotorflight on the Nexus Fly Barless. So I'd like to make sure I say thanks again to Rob. Rob, it's awesome having you around the channel, man. You're a true asset and a good friend. Thank you for joining us and talking us through and sharing your knowledge with us. We definitely appreciate that.
Yeah, been fun.
And then I also want to say thanks to Radiomaster for including me in the Nexus testing group and sending these prototypes out so I could get involved and work on these configurations early and get to understand the hardware so that we can produce videos like this. So thanks to Radiomaster for including me in that process. I'm very grateful to be in that little group, that special little group that they put together for getting the Nexus fly barless put together as a commercial product. With that said, that's all I've got for tonight. I hope you guys have a fantastic weekend, and I definitely get out there and fly something. Take it easy.